This is kind of a tough question, but hopefully what I type out can help you with whatever variation of the question that you're working on. We're asked to calculate a probability. A probability is found by taking the number of options we're interested in and then divide by the total number of options. Okay? Like if your closet has 3 blue shirts and it has 10 total shirts, the probability that you randomly pick a shirt out and it's blue is 3 out of 10 because there's 3 blue shirts, that's the options we're interested in, divided by a total amount of 10 shirts in the closet. We have a 5-child family. So in order to calculate the probability, we've got to figure out all the different possible options for how this family came together. Okay, there's lots of different ways, right? The first option would be boy, 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 boy. Right? We have all boys. Pretty unlikely, but could happen. Boy, 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 girl is the second option. But look, a third option could be boy, 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 girl, boy. If the order that the family comes in, it matters because there's only one way to get 5 boys. There's 5 different ways of having 4 boys, 1 girl. So we have to count out all those other options. Boy, boy, girl, boy, boy. We can do boy, girl, boy, boy, boy. And then we get girl, boy, boy, boy. Having a girl first, and then the rest be boys. Okay, so that's all the options with having just 1 girl, 4 boys. Now let's start thinking about what if we had 2 girls. Okay, remember we need to calculate the total number of different ways this 5-child family could happen. Okay, because that's the bottom of our fraction. And then once we have all the options listed, then we can find out the number of different ways we could have 2 girls, 3 boys. So this is helping us calculate 2 things at once. We need to list out the total number of ways the family can happen. But this also helps us calculate the number of ways we can have 2 girls and 3 boys in our family. So we do boy, boy, girl, girl. That's 2 girls, 1 boy. Boy, girl, boy, boy, girl. Girl, boy, 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 girl. But there's still more, okay? Because you could do boy, boy, girl, girl, boy. Boy, girl, boy. We haven't done that one yet. Girl, boy, boy, girl, boy. There's still more. We did 2 girls on the 3rd and 4th, so we do boy, girl, boy, boy. This is crazy. 15 would be, we could do girl, boy, boy. The trouble is, like this class, we can't go in depth with all the different types of options that there are in math. When you study probability theory, if you do later on, there's a way of calculating this using combinatorics, okay, like a combination, the combination formula. You might have heard of it. If you have, you can message me and I can show you how we can use that here. But let's see, the only other option, girl, boy, boy, boy. I think we've got all of them now. Let me just double check. These are all the different ways that we could have 2 girls, 3 boys. Just double check and make sure I got all of them. Yeah, okay. And then you could just switch all the girls, all the letter G's with all the letter B's. And just repeat the process for having 3 girls and 2 boys. Because remember, we need to calculate the total amount of different ways that we could have families. That we could have a 5-child family. So I'm looking at our list and I'm replacing all the G's with B's and then vice versa. Then over here for 25 we've got boy, girl, girl. 26 is boy, girl, girl. So that's all the ways of having 2 boys and 3 girls. Luckily it gets easier here because now we've done having 5 boys, having 4 boys, 3 boys. We've done 2 boys. Now we just need to do 1 boy. Maybe it happens as a last child. Maybe it happens the 28th, 29th, 30th, and the 31st. And then one final option, what if we had all girls? Oops, I need a number. Okay, so if you get the 5-child family one, there's 32 different ways of having a 5-child family. Now the number of options we're interested in, that's the number of 2 girls and 3 boys. So I separated those as we were writing out the options. These are all the different ways of having 2 girls and 3 boys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 ways of making that happen. So if you simplify that fraction, both the top and the bottom can be divided by 2. That's 5 out of 16.